Hello, beautifuls. This is Atleen, and welcome back to my channel. So, let's get into advanced subnetting, advanced subnets, because the goal here, how much more advanced, right, can we get? But so we know how to calculate how many subnets we create, how many hosts are created per subnet, but we need for the real world, we need to be able to say, here are the networks that I created when I make use of this mask. And here we have the usable range of addresses in that network. In those networks, we can visualize something simple such as a class B network. So we know that a class B network is the range is 128 to 191. And to calculate usable address ranges, we have 172.0, 172.25.0.0/16. And we want to create some more networks, and we want to chop this up into 256 networks. So what we're going to do is say we have these two extra octets, and we're going to use that third octet, which is 8 bits, and incrementing that by 1, and this creates a new network and creates another. So we just use the third octet, and we see the first network is going to be .1.0, and the next one, well, the first network is 172.25.0.0, and the next one is .25.1.0, 2.1, and then the next one is going to continue this way all the way through 255.0. So as you can see, it's 172.25.0.0, and then it's going to be 172.25.0.0, 172.25.1.0, 172.2.0, and so on, all the way up to 255.0. That gives us 256 subnets. We added 8 bits. We borrowed 8 bits. 2 to the power of 8 is 256. So we created 256 networks, but many times we're not going to have the conveniency of having that divided line falling neatly on an octet boundary. Various times it will not. We'll have not 24 bits, we'll have something like /18 or /27. So what do you do with this? So what we're going to do next is something easy to visualize, and then a bit more challenging one. So what we're doing is simply or counting by 1 1/3 octet. So the first thing we need to understand is, what's the interesting octet? And here's the definition. The interesting octet is the last octet in our subnet mask to contain a 1. So we think of our subnet mask in binary. What is the last octet to contain a 1? Well, in this case, the last octet to contain 1 is the third octet. So step 1, determine the interesting octet. Third, got it. Next, step 2, determine the block size. So remember, previously we are just counting by 1 in the third octet because that is our block size. Here's the definition of a block size. That's the number that we're going to be counting by in that interesting octet where we're going to be counting our block size. So, what is the block size here? Here's how we calculate it. Is 256 minus whatever the subnet value is in that interesting octet. So 256 minus 255. That's what the subnet value is in the interesting octet. So our example is a bit easy. Look at there's 255 in our octet. And what is 256 minus 255 equals 1. Okay, so today is December the 24th, 2021. And if you celebrate the holidays, if you celebrate Christmas, I wish you a happy holidays. And I won't be working tomorrow. I won't be doing a video tomorrow, which is Christmas. I'll see you Sunday, the 26th. Keep studying. I wish you well and happy holidays.